Hello, everybody. My name is Joseph Sondry. I'm president of the National Spectrum Management Association. Thank you for joining our continuing webinar series. We're excited to have you, and we're very excited today to have Mark Gibson presenting spectrum management and using the example of mid-bands. What's up with the mid-bands? Mark's a really accomplished person in the spectrum management arena with over 36 years of experience. He's responsible for developing domestic and international business opportunities for CommScope, and in addition to leading technical and business development efforts for numerous wireless and spectrum-related products and services, he's led efforts to address spectrum sharing between the federal government and commercial users. He leads CommScope's CBRS efforts, and Mark will explain more about, for those who are new to different spectrum bands, what CBRS is later on, but that's a specific band. But he's leading those efforts on the spectrum access system and environmental sensing capabilities type of subject matters. He's a board member of the CBRS Alliance. He's an officer on the board of the Wireless Innovation Forum. He's a member of the Commerce Spectrum Management Advisory Committee, where he has also co-chaired working groups related to spectrum sharing and data exchange issues. He's led spectrum management efforts, including the development of the SCS and ESC TV whitespace spectrum sharing analysis protocols and sharing criteria. And again, those different bands will be explained for folks who are new to spectrum management later on in the program. And he's done development of CommSearch's engineering services and software products. He's led efforts in working with the American Hospital Association as their technical partner for WMTS frequency coordination. He's authored several papers on spectrum sharing and relocation. He's advised numerous wireless participants in their system designs. He's also a life member of the IEEE, International Institute of Electronics and Electrical Engineers, which is pretty much the world's most premier organization on spectrum matters. And he has an amateur radio license and is an instrument-rated commercial pilot. And he'll tell you about how he pilots his bike as well. Welcome, Mark. We're really pleased to have you, and thanks for being here.
That's a pleasure, Joe. Thanks. And so thanks to James behind the scenes making sure this works. What we've done here is put together for you all a presentation that is under the rubric of spectrum management, but mostly focusing on the mid-bands. But with that in mind, I wanted to just kind of start off and give you a little background on how we're going to do this today. So I've got about a 40-minute or so presentation. We're going to take a few breaks. We have slides in here for the breaks, and the breaks are to give you guys some ability to walk around and also ask questions. So we'll get some defined places to ask questions, and Joe will act as the MC and let me know what questions are out there. Also a little bit about NSMA. So actually, I've been a member of NSMA since it formed. I remember when NSMA formed in '84. It was really around working in the microwave bands, and I remember having conversations with Bill Lai at the time and a few other folks about getting the organization stood up. I was a CUB frequency coordinator then, doing mostly frequency coordination for the mobile applications for cellular. And the NSMA is probably the preeminent national spectrum management association in the world, but mostly focused on the United States. It's voluntary. We work on mostly with microwave, but the intersection of microwave and satellite, licensing, working with the commission, and of late, NSMA has been looking at a lot of the great new things that are going on in spectrum with respect to, for example, Joe mentioned CBRS, TV whitespace. We'll be talking in some of these webinars about 6 gigahertz and the like. And again, NSMA is often mentioned in rulemakings as the people where a lot of this stuff is dealt with. In fact, as we talk about 6 gigahertz, we're using a lot of the NSMA work on that. And as we have here, the association is the annual meeting this year because of COVID. So I was sorry that didn't happen. So this is kind of trying to take the place of some of that. But I can't say enough good stuff about the NSMA, and Joe's leadership is taking us in great new directions. So that's really who the NSMA is. So the agenda, I'm going to do a little bit of the basics of US spectrum management, and we're going to focus on the mid-bands, starting with what are the mid-bands, and then we're going to break it down by most of the spectrum going on in the mid-bands. You know, the mid-band spectrum has been in all the news lately. Largely because it's really the next sweet spot for spectrum use. Some people are trying to actually add the 12 gigahertz band to the mid bands. I think that's a bit of a band too far. But when you think about the 12 gig band, which is interesting, it's really got no home in terms of a designation. So maybe someday we'll talk about that. Right now, there's a lot of stuff going on there, but this is mostly the mid bands. So to get started, sort of the basics of U.S. spectrum management, I think it's important to understand with these mid bands, how things are going on in the United States. In the United States, all of the spectrum management and regulatory stuff happens under the Communications Act of '34, which was actually modified in 1996. And in the Communications Act, it established, how the commission works. It also established the regulatory authority over the bands. And so, in that, when the act was established, the NTIA and the FCC were given respectively responsibility for the commercial or non-federal and federal spectrum. So NTIA deals with the federal spectrum, and the FCC deals really with everything else. It's typically called non-federal. Sometimes it's called commercial. But in the context of the rules, it's mostly called non-federal. And so this has been going on since then in various instantiations. The interaction is governed by a memorandum of understanding, and the MOU was last done in 2003. So the MOU is 17 years old. Joe mentioned the Commerce Spectrum Management Advisory Committee, which is CSMAC, which actually works under NTIA. The CSMAC actually had a working group focused on revising this whole bifurcated spectrum management, spectrum regulatory process. And if anybody's interested, urge you to go to the NTIA's website and look under the CSMAC heading, and you'll see a bunch of information on what is being considered, at least at some point in the NTIA, for addressing some of these bifurcated spectrum management things. Nonetheless, a lot of the mid bands, the allocations are shared. And the interesting thing about this is there's no statutory federal and non-federal bands. You can look at the table of allocations and you'll see that they identify federal or non-federal use, but it's not statutory. It's mostly just by the way things have happened. And so we have in the various organizations, the NTIA rule spectrum management is governed by something called the Red Book, only because the cover is red, and anymore if you download it, it's not red anymore. And it's a fairly lengthy description of how the NSMA or how the NTIA works, and a little bit about how it interacts with the commission. And then the commission's rules are governed under the Code of Federal Regulations, and we're CFR 47 or 47 CFR. And so that's where everything happens under the commission. And there's this entity that exists between the two called the Interdepartment Radio Frequency Advisory Committee, or the IRAC. The IRAC is chaired by the NTIA. All the federal organizations that have spectrum needs have a chair have a seat at the IRAC, including the FCC. And so when we're dealing with the shared aspect or the allocations of federal versus non-federal, to the extent that there's any sharing that has to happen between the federal use and the commercial use or non-federal use, it happens at the IRAC. And I won't get into that. That could be a whole nother separate webinar. But that's a little bit about how it happens. And so what's happening now is, as we are moving in toward, in the 20th century, 21st century, we've got new pressure, if you will, on sharing spectrum. So this line that exists for federal and non-federal use is blurring. And it's blurring a lot more with things like CBRS, the stuff that's going on in the 3450 to 3550 meg band, the 7-8 gig bands, and whatnot. And so this blurring is kind of causing more need for these two agencies to work together. And you'll see in the whole description of the mid bands situations where the agencies need to be working together. So I wanted to set this up as a bit of a backdrop. This certainly isn't the primer on spectrum management that we could do, but it gives you a bit of context for why this relationship is important when you understand what's going on in the mid bands. So what are the mid bands? Well, here's the big old table of allocations, the wall chart that's been done by NTIA, and this has become iconic. I've actually seen this on television. And I was at a meeting not so long ago where actually a woman had made this into a scarf. And also, if you go to ITS has mouse pads that have this. So it's become really a meme, so to speak. So we're going to be focused on the 3 gig band, 3 to 8.5 gig, which for our discussion right now is the mid bands. I think you could poke mid bands a little bit above that, maybe up into at least 10 gig. But right now we're going to be talking about the 3 to 8.5 gig band. So, and there it is blown up a little bit. And what you can see is, if you're not very familiar with this, there's a lot of colors. The colors on the left there you see indicate the service types. And then across the bottom, you'll see red, green, and black. Red means federal exclusive, green means commercial exclusive, and black means that it's shared. And so that's how to look at this. But basically, this is the same. This is a pictorial representation of what's in the, for example, FCC Part 2.106, which is the entire table of allocations. So the mid bands, like I said, are 3 to 8.5 gigahertz. So the breakdown of the bands go like this. We'll talk about 3100 to 3450, 3450 to 3550, and 3550 to 3700, which is the CBRS band. And I'll explain that the NTIA did a study on the lower 2 bands most recently. I'll talk about the 3.7 to 4.2, the C band. That's a lot of activity going on there. The 5150 to 5925 meg band is the current unlicensed band, although there's a lot of stuff that goes on there that's not unlicensed, but that's the UNII bands, UNII 1 to 4. The 5925 to 7125 meg band is the current 6 gigahertz band. It's broken up into 4 chunks as well. And then the 7125 to 8500 meg band is the final band on top of that, which is a federal band for now. And those are the mid bands. So we'll start off, not necessarily in order, but start off with CBRS, because that's where a lot of activity is happening now. As I said before, the CBRS band is the 3550 to 3700 meg band. And so what's happened in the band so far is this is where we have what's called tiered sharing. As you can see, there's a triangle there, the pyramid, where this tiered sharing was conceived by an organization back in 2012 called the President's Council and Advisors for Science and Technology, or PCAST. And PCAST operates in the Office of Science and Technology, or OSTP, from the White House. And so the PCAST folks got together and thought, you know, we need to find better ways to apply 21st century computer technologies to spectrum management. And so they came up with this notion of this CBRS band with this, what they called 3-tiered sharing, with incumbents at the top, some sort of an auction license tier in the middle, and at the bottom, some sort of a tier that's sort of pseudo unlicensed. And the only reason I say pseudo unlicensed is it's not totally unlicensed, because in order to be able to operate under the GAA tier, you have to be eligible to hold a license in the United States. Whereas if it were fully unlicensed, that would not be the case. And so the pyramids, everybody lower than the next one up, it has to protect the one above them. So everybody has to protect the incumbents. And the incumbents in this band consist of Navy radars that operate on aboard aircraft carriers that operate in the coastal waters, both Atlantic, Pacific, and the Gulf. Fixed satellite operators for Earth stations. This is the downlink band, so these are all receiver stations. And finally, Part 90 grandfather wireless broadband systems, who operate in there as well in the 3700 or 3650 to 3700 portion. The band has 150 megahertz of spectrum, channelized in 10 megahertz chunks. And for the broadband wireless, so the ones that operate in 3650 to 3700, their allocations revert to GAA in 2020 to 2023. And if there's any questions about the specifics about that, we can get into it. This isn't a primer on CBRS, so this is just a little bit of information. This deck will be made available, and you can see some more stuff around it. But the licenses will be based on counties. And so by way of update, and so the band is managed by something called a spectrum access system. And I won't get into the great details of how the SAS works, but basically the way it is intended to operate is a centralized dynamic spectrum management system, which will take requests from devices for spectrum. That request includes the location of the device, the type of device, and some information about the spectrum that it wants. That information goes to the spectrum access system. In the spectrum access system exists information on all the other users, including the incumbents, as well as information from other SAS type systems, and then information from the environmental sensing capability, which is a sensor network that has been deployed along the coasts to monitor the radar operation. This is basically a very expensive and distributed radar detector network. And so a device asks the SAS, I'm operating here, I need spectrum, what's available? The SAS analyzes all of the environment and then tells the device, okay, based on what you've told me, this spectrum is available and you can operate on it at this power. And that's generally how it works. So again, the SAS, we can get into more details on another webinar. But I'd also like to say that between when Joe asked me to do this and when we're doing it now, the auctions have completed for PALs. They completed actually a little less than a week ago on Tuesday, August 25th. They generated about 4.585 billion for the Treasury. By comparison, and that for 100 or for 70 megahertz of spectrum. By comparison, the AWS-3 generated about 45 billion, and the 700 megahertz about 20 billion. And actually, it's the dollars per megahertz pop is the major comparison point. And for the CBRS auction, actually, that was a little bit lower. But the auctions were done on counties, and there were 7 licenses available for each county, which means that's a total of 22,631 licenses that are available. If you do the math, which is a lot of licenses, it's the most licenses ever auctioned by the commission. And in fact, the most bidders ever came forth to want to bid on the spectrum was 271 bidders. So there's a lot of firsts in this auction. And so the auction's closed, and 20,625 licenses were won. 2006 licenses were not sold. And then there's a map I borrowed from Wiley there on the right that shows roughly the areas that were sold. This kind of blew a lot of people away. Not everybody thought we'd sell 22,000 licenses, and I was one of them, frankly. A lot of licenses apparently sold in rural areas, which is great because that means that there's rural PAL spectrum available for broadband wireless use, which is a lot of WISPs were concerned about that. And so now, we're waiting with bated breath for the commission to issue the public notice that's closes the auction. That should have been done by now, but that will start the ball rolling or the clock ticking on payments and all that to get the auction out there. And so as of now, given that we started CBRS in earnest back in January, there's over 40,000 CBRS devices deployed, over 98% of which are for outdoor operation. And a lot of that is because of the transition to CBRS from Part 90. So here's our first break at 15 minutes. I guess this is where we stop and ask questions.
That's it. Fantastic. Good breath and cadence. Thanks, Mark.
Sure.
First question we have is from, I believe, Joe Crossan, and he's asking, what are the license terms for these for each license you mentioned?
The 10 years renewable. The build out requirements are like they are on other things, substantial service. You can lease them. There's what they call light leasing for these, which is those leases can be managed by the Spectrum Access System. And so that's generally the terms on the licenses.
Great. And what are the no-nos? What can't you do with a license? So what are some typical pitfalls?
That's a good. Well, you can't interfere. For the most part, though, they're the same terms as they are on other spectrums. So if you bought spectrum in the AWS auction, you have the same limitations there. I should have mentioned this is TDD, so there's no uplink downlink. So you've got to make sure that you use a TDD type of technology. And right now, the primary TDD technology is LTE or some flavor of WiMAX. There are some proprietary technologies out there, but the only limitation is it's got to be TDD. Other than that, you've got to be eligible to hold a license, which there's citizenship requirements and all that. There's really complex ownership requirements, but nothing different than any other auction.
Can you go over just a sentence or two about the difference between what TDD is and what FDD is and the other types are?
Sure. So TDD is time division duplex, which means that what you do is you take your 10 megahertz and you carve it up in time. And so at time T1, let's say, you're transmitting, and at T1 plus X, you're receiving. So let's say that you have a situation where you have a base station talking to a handset. The base station talks to the handset at time T0 or T1. It waits, and then the handset talks back in another time slot. So essentially what you're doing is you're using the same frequency, but it's basically like when we talk. Joe talks, I listen, and then I talk, Joe listens. At least that's the way it's supposed to work. And it usually works that way. But that's kind of how TDD works. FDD is frequency division duplex, where you've got base stations talking all the time, and you've got handsets talking all the time, and the information gets sorted out by virtue of the radios just decoding and understanding. So that's the main difference. Is you don't have an uplink downlink spectrum. In TDD, it's all one band.
Thanks a lot, Mark. Mark Rasick also noted that no UAS is allowed. Do you want to chat?
Yeah, so that's a good point, Mark. There's no airborne operations allowed in this at all. No, not even UAS is basically another word for drones. And so there's no airborne operation at all. And I should say also no mobile operation for the base stations, or for what they call the CBSDs. They cannot move. There have been some interesting applications where these things have been put on HAFs as high altitude platforms or aerostats. That operation is questionable. And also, if the device moves more than 50 meters, it has to recheck the SAS, to make sure that the spectrum is still available. But no airborne operation at all.
Great. And James, I don't know if you're able to open up the microphones for anyone else who wants to ask a question. I think Mary Dilling was looking to ask a question on
yeah, everyone's unmuted.
Okay.
I mean, everyone's allowed to talk. I can't control their microphone from here.
Okay. So Mary, if you're out there, if you want to try to ask a question, if that's helpful. And if that doesn't work at this break for you, maybe you can figure it out between now and the next break. She says, oh, she can't unmute because failed to detect microphone. No questions at this time. Okay, good.
Okay.
All right. Well, that's the first break. Everyone else will, in the audience, will go back on mute until the next break, and we'll let Mark continue surfing spectrum waves.
Actually, Mark McHenry raised his hand. I don't know if Mark can talk. Mark, did you have a question? All right, I can't hear you, Mark. So if you have a question, put it in the chat, and then Joe will just transmit it to me. Okay, we'll keep going then. So the next band up is the 3100 to 3550 meg band. This is mostly federal. It used to be federal exclusive. There was a lot of non-federal operations in there. And I won't read all of this, but basically what happened is this administration and the previous administration, see the need to make more spectrum available for 5G. And so there were really two major acts from Congress. One was the Mobile Now Act, which has a long acronym, and the other is the Ray-Baum Act, which also has an acronym. And both of these acts tell the various regulators to find more spectrum. The Mobile Now Act constrained it to certain spectrum areas, at least 100 megahertz for unlicensed, at least 2.25 below 6. Ray-Baum's had, tasked the NTIA with doing some studies. And so this is what has driven activity of late in the 3100 to 3550 meg band. If you go back and look, NTIA has a really cool spectrum compendium that goes up to 7125 in the chunks of the bands as they're allocated for federal use. And if you look at this band, the allocation is 3100 to 3300, 3300 to 3500, and 3500 to 3600, I think, or 3650. So it overlaps into CBRS. So there's going to have to be some work done to deconflict some of that. And I'll talk a little bit about some of the studies that have been done. And the other thing too is that we have been waiting for the administration's national spectrum strategy since January, and haven't gotten that yet. So we'll see. It could be that part of the that spectrum, national spectrum strategy is what they announced back at the beginning of the month, which I'll talk about in a minute. So in the 3100 to 3450 meg band, the current use right now, as I said, is federal only. And basically there's a lot of operations that are meant for radar. The band allocation is primarily radio navigation, or radio location, which implies radar or something like radar. So you've got, for example, the Aegis radar, which is a ballistic missile defense type radar. These are on board destroyers, or battleships, I'm sorry. And then AWACS, and I can never remember what AWACS stands for, is essentially an airborne spectrum or battlefield management capability that they operate in there. And then also within that portion of the band is some of the radars that are on board the aircraft carriers. So that's a little bit about what I don't have a picture of is something called station keeping, which is radars that are used for aircraft to fly in formation. So this is a little bit about what's in that portion of the band. The next band up is the 3450 to 3550 meg band. And it's a little bit more of the same. This is where the spin radar, the radar that's on board the aircraft carriers, the station keeping, like I said, is the radars that are used for aircraft to fly in formation, for example, to do aerial refueling. Very cool stuff. Then the other thing too, it was in the no, it's actually it's the band, right? No, it isn't this band. It's the FCC had three types of allocations. There was an amateur allocation, there was a radio location allocation, and there was another allocation. I forget what it was. They have a rulemaking that's out now that essentially removed those allocations. So the poor amateurs lose another, 100 megahertz of spectrum for that. And then there's a lot of radio location done in the band for things like proximity detection, and also in the 3550 to 3500 to 3550 meg band, there's a lot of high-powered weather radars. Their biggest one is a 12 gigawatt radar that I believe is in Florida. So all of those got secondary allocations, and that's part of an ongoing rulemaking right now. So the current status of the band is interesting. So back in January, NTIA issued a 295-page document on the 3450 to 3550 meg band. Most of that document was or is analysis of the ability of that band to be shared. And a lot of their conclusions, or at least analysis, was in the front part of the document. But basically that document said that the band is available for use. We think it could be operated under a shared use. There probably needs to be some relocation. And oh yeah, there's a bunch of classified systems in the band that need analysis or need to be analyzed. And then there was a companion study that was really part of the act that was issued in July, early July, a little over, almost 2 months ago, for the 3100 to 3450 meg band. And so, taken together, those two studies said that the 3450 to 3550 meg band could be made available on a shared basis with some relocation, possibly more relocation than sharing, although that would need to be studied, the feasibility of relocation, because that's not what the study was all about. And then the 3450 to 3550 meg band, I'm sorry, the 3100 to 3450 meg band could be a place where things get relocated to. A lot of these systems operate across the whole 3100 to 3550 meg band, so they may not need the whole full, however many megahertz that is, so they could be compacted down to the lower portions of spectrum. And anybody that participated in AWS-3 work many years ago, I guess it was 2012, some of that same type of considerations were given. So what happened at the beginning of this month, I think the timing was August 7th, we learned, most of us for the first time, that the White House had been doing studies with this organization, a group of folks, they called themselves AMBIT, which was America's broadband investigation team that comprised, they said, about 180 experts across government. No industry people were involved, working with an organization, working with NTIA and DoD, and under another organization called the National Defense Industrial Association, or NDIA, to study the feasibility of making the 3450 to 3550 meg band available. And they concluded that the band could be made available with relocation, and that could be done quickly. And so there's a rulemaking actually making its way through the commission on that band, probably that could be coming out as early as the September meeting on September 30th. We don't know exactly what it shares. There may be people on the webinar that might be part of that or might know more about it. We've done a little digging and found out, how some of this is being done. A couple of industry associations are writing the commission or NTIA asking for a little more study. But the band is expected to be auctioned for exclusive shared use, possibly shared with federal operations under higher power, high power being around 61 dBm, which is a slightly less than the power that's being considered for C-band. So like I said, the rulemaking we're hearing will be out on September 30th, so we'll know more what's going on, and that band is another 100 megahertz of spectrum that could be exclusively licensed, so that's pretty exciting. So on the other side of CBRS, or the other side of this band is from CBRS, is the C-band. The C band is the 3700 to 4200 megahertz band. There are about 16,400 licenses, to be actually at 16,447, if anybody's counting, licenses in that band. These are earth stations, receive earth stations. This is the location of those earth stations. And the earth stations, basically we know about that because the commission asked for any owners of these earth stations to ensure that the information in the filing system was correct and accurate. One of the things they were trying to do was determine the extent to which these systems could be restricted in operation to the upper portion of the spectrum, the upper 200. They found out that such is not the case, but nonetheless, we now know at least how many there are that expect protection. We've done some studies of the band to identify how sharing would work, and we've been able to identify, we being CommScope, CommSearch, we've been able to identify that there are probably sharing zones would be somewhere on the order of 2.5 to 20 kilometers, depending upon the operational parameters and the transmit operational parameters of the earth station and the transmit parameters of the base stations. And so what's happened is that move up. So the band has been open for auction. You can see there on the right the potential band plans. Basically, what's going to happen is the band from 3700 to 3980, 280 megahertz, will be auctioned in 20 megahertz blocks. There's no spectrum cap on that, so you can buy as much of that as you want if your pockets are deep enough. The upper 20 megahertz will be a guard band against fixed satellite operations to avoid interference, which means that the protection zones could be a lot smaller. The band will be made available. In fact, the auction for this band starts December 8th this year, and that's probably absolutely going to happen. There's a public notice that's been made that's open. The commission is coming out on it, so we expect to have the auction on that starting in December. The auction areas will be partial economic areas. If you do all the math, that's a little less than 5,700 total licenses. And there's two categories, Category A and Category B/C. So you can get the A block or the B and C blocks. The interesting thing about the band is, though, that there are, like I said, there's over 16,000 earth stations in the band, so they've got to be moved. And so before any deployment can happen, those earth stations have got to be relocated out, and most of those earth stations are going to be repacked into the upper 200 megahertz. So there's a lot of activity going on in the industry now to effectuate how that's going to happen. And in fact, there are multi-stakeholder groups that have been formed, under which there are technical working groups studying how that's going to happen, and also interference issues at the edges, which I'm not going to get into. The satellite operators, and this was rather contentious in the rulemaking, when I won't get into that, but the satellite operators said, well, look, with more money, we can get out quicker. And so the commission in the rulemaking identified two phases. And I apologize, those dates are wrong. The commission changed those dates from September 30th to December 30th, so I should have checked that. So the phase one clearing, the PEAs could be made available by December 30th, 2021 for the 46 of the top 50 PEAs, or partial economic areas, which means that with additional monies totaling $9.7 billion, parsed out to the earth station or the satellite providers, they could expedite the relocation so that you can get some deployment in the 46 of the top 50 markets within about a year after the auctions conclude. And then the remaining markets could be done within 2 years. And like I said, it's about $9.7 billion. So that's basically how the C-band is going to work. And again, this is one that's hot and heavy right now, with a lot of activity going on, especially in the technical working groups. So now we're out of the 3 gig bands. We're going to go up one more band, or going up to 5 gig, and this is going to be pretty quick. The U-NII band, or the 5150 to 5925, this describes the unlicensed national information infrastructure band. And you can see there the bands, there's a lot of activity going on in the bands. Here's a band plan thing that I put together based on something that someone in the Wi-Fi Alliance had done to sort of show how the band is channelized based on the U-NII designations and also what else is there. So the portions of this band that are of major interest are starting from the top down. At the very top is the 5850 to 5925 meg band. That portion of the band has been reallocated to C2VX. I think that's what it is, C2VX, which is a vehicular type of LTE that will be operating up there. The designation had been for something called dynamic short range, or a dedicated short range communication service, the 5850 to 5925 meg band. But for all intents and purposes, that band was really very underutilized, going back almost 12 years, I mean, more like 15 years. So there was interest in making that band more useful, if you will. And so the commission made a designation to put 75 megahertz of it, I think, to unlicensed use, and then the other 25 megahertz of it for C2VX, or maybe the other way around, I can't remember. But so that's been somewhat contentious. And the other thing that's been a little contentious is the TDWR band, or the Terminal Doppler Weather Radar band, which is where there's a lot of unlicensed point-to-point operation. And in order to share with them, you have to use something called dynamic frequency selection. And the other thing that was kind of interesting in the band, there was a lot of interest in the band by the 3GPP folks for unlicensed operations. So they broke the band into bands for unlicensed, and you see the designations there: band 252, 255, and 46 and 47. So there's a lot of unlicensed use set up in that, 3GPP use set up in that band as well. Oh, here we go. So for the TDWR band, I'm sorry, for the DSRC band, the unlicensed is the lower 45, and the CV2X is the upper 20, and the DSRC gets 10 meg in the middle. The DSRC folks are not very happy with that. They would prefer to have had more, but that's the way the commission came down on it, and so that's the way it's going to be. And the CV2X is essentially for vehicular type LTE applications. Cool stuff. It's basically DSRC in LTE spectrum. And so the NPRM has been out for a while, so and it's been in all the papers as well. Okay, it's now time for a second short break.
Great, thanks, Mark. Just real brief, the definition for AWAC is Airborne Early Warning and Control System.
Thank you.
Thank you. Paulette Woody had mentioned earlier that the quiet zone coordination is still in the process. I guess that was from an earlier discussion.
Quiet zone for?
I believe that had to do with the right before the first break we were talking about.
Well, there are quiet zones associated with all of these. With CBRS, there's a bunch of quiet zones. There's Green Bank. There's the FCC field offices. There's Table Mountain. So those are all part of the coordination. If they were talking about quiet period, we are still in the quiet period for the auction. The quiet period lasts until the down payments have been made. So that'll be 10 days from when the public notice is issued. So if the public notice is issued today, it'll be sometime in a couple of weeks. So I know that's quiet zone versus quiet period. There are quiet zones associated with all of these. Most of the quiet zones are identified in the rules, mostly under Part 2, which is where they define that. Some of them are within the rule part associated with the type of operation or the service.
Okay, that's pretty comprehensive. Thanks for that. And also, Paulette was zoning in on a particular, she just made a note. She was talking about the NRQZ coordination, I guess 47 CFR 1.924.
Yeah.
And she's the coordinator at the NRAO for Green Bank. So
okay, well, that's good to know. We have been, fiercely have protected Green Bank because we believe in radio astronomy. One of my good colleagues at Google, Andy Clegg, I know quite well, and then that's his forte. And I know Harvey List and some other folks. And so we protect Green Bank, we protect Arecibo, but Green Bank is protected by virtue of the protection zones that are instantiated in the SAS. So the only way to operate in Green Bank is to coordinate with the spectrum coordinator there. So there's a couple of things that probably come her way.
Yeah, I bet. And I don't know, just a quick check. Is anyone wishing to speak or ask a question verbally? And if so, James, is that possible at this moment?
Yeah, everyone's able to talk. They just need to unmute.
Okay. And while it will give people a moment or two if anyone wants to speak live. Also, Mark Rasek made a point. There have been very aggressive plans for the 3450 to 3550 megahertz. And he wants to know, is it possible to cover 98% of the population in full power, without major relocation?
That's a fundamental. I reckon Mark means without full scale relocation of the incumbents. And if you go back and read the NTIA study, I would say probably not. And so, but I want to talk to you anyhow, Mark, because we have a couple things to talk about. I don't think so. Just judging from what the study said, and notwithstanding the classified systems, which we don't know much about, sharing with the AWACS is going to be problematic. So the question is, when can they relocate down to spectrum below? And for those that have been paying attention to this, there's an organization called the National Spectrum Consortium that has they basically manage some RFPs that come out of the government for spectrum sharing. There is one of them for Hill Air Force Base in Utah for this very type of operation, sharing with AWACS. So I don't know whether they're thinking we're going to share with the AWACS or going to relocate them, or if it's transitional. So that's a big question that still needs to be answered.
Thanks, Mark. I think we can proceed to the next third.
Okay, so actually, I think we're getting toward the end. So moving up in the band is the 5925 to 7125 meg band. That is the 6 gig band, and that is another one that's been the subject of a lot of discussion. That is the sweet spot band that's left, the only band left over for long haul microwave. The 4 gig band has been pretty much abandoned. There's still about 70 some links, I think, that are still in that band that have to be relocated to accommodate the operations for mobile operations. So the 6 gig band is the last band for long haul microwave, that we have, and that sits across the whole band. I have a chart here. Well, here's an example. Here's a picture of just how complicated that is. And this is from like 2 years ago. So for microwave, there's two chunks. There's the lower 6 gig, which is 5925 to 6425, and the upper band, which is 6425 to 7125. And you can see there's a lot of activity in the bands. And for anybody that doesn't know, that triangle that goes between DC, New York, and Chicago is for high frequency trading. So those guys got a piece of the action. But you can see that there's a lot of areas, and if you zoomed in on areas, there'd be a lot of areas that are fallow, but in major downtown metropolitan areas, there's a lot of 6 gigahertz use. And so you can see the number of paths. Actually, it's more like 29,000 paths and over 106,000 frequencies across both band segments. Here is basically how it's being used. There's 4 chunks, UNII 5, 6, 7, and 8. So it continues the UNII designations from the 5.9 gig band below. You can see from the picture to the right there of all of the services that are in the band. So it's not just microwave, it's microwave. There's some broadcast, there's cars that is in there. There's some passive, the passive sensors of the Earth Exploration Satellite Service, the EESS. Cirrus has uplinks in the band. There's a lot of satellite. In fact, all the 4 gig receive satellites uplink in this band, and we've had to share with them over the years. There's radio astronomy allocations. So this band is a potpourri of all types of use. Without getting too deep into the details, the commission reallocated this band to be shared with unlicensed systems. 2 flavors of unlicensed, something called low power indoor, which operates up to a watt, exclusively indoors. They can't operate outdoors, and they should be configured so as not to operate outdoors. And then something called standard power, which is maximum 4 watts, which can operate outdoors, and they can actually operate indoors as well. And so the low power can operate across the whole portion of the band. The standard power can only operate in the UNII 5, which is the microwave bands, and the UNII 7. So 5925 to 6425 and 6525 to 6875. And so that's the segments of the band for standard power. Standard power must be under control of something called an automatic frequency coordination system, or an AFC. AFCs are similar to SASs, or I'm not going to talk about it, but TV whitespace databases. So those are the centralized dynamic spectrum management systems that are being deployed to manage devices so they can share spectrum with incumbents. And so that's basically how the 6 gig band. Again, this is really a survey of the bands, and those numbers there are the more updated numbers from the previous one. So you can see there's still a lot of microwave operation. It's going in at the tune of about 600 a month. So there's a lot of activity going on in the band. It's about steady, but it's still active. So that's the 6 gig band, and then the last band is the 7125 to 8500 meg band, which is the 7/8 gig band. So the reason I put that out there is that, and that's a federal primarily only. You can see by the red designation there. That band sits, as I said, right atop of the 6 gig band. And the reason there is interest in it is it's possible that that band could be opened up for sharing for commercial operations that are commercial 6 gig unlicensed, microwave operations to be moved up into that portion of the band. We've been looking at that. We've been talking to the NTIA and other users about relaxing the federal only use of that band. And, suffice it to say that more talk is needed. But there is definitely, that's a lot of spectrum there. It's lightly used. If you look at the NTIA's spectrum compendium, it doesn't go all the way up there, but we've done some studies to indicate that there's probably a third, if not a quarter of as much microwave in that band as there are in the 6 gig bands, in 1.375 gigahertz of spectrum. So there's a bunch of other stuff up there too, some that is very hush-hush, but we still think that if they can make microwave work there for federal operations, they should be able to make microwave work there for non-federal. So we CommSearch are talking to them about doing that, and this is one of the ones where stay tuned. But I wanted to put that out there. There's a lot of use there in that portion of the band. And we think that that band, as I said before, could be a safe harbor relocation band for commercial microwave. A lot of hurdles to cross, not the least of which is a reallocation for federal or for non-federal use. But there's also frequency coordination protocols and all kinds of things. So fun stuff, but probably is not going to happen anytime soon. All right, well, I'm moved up the last break just before the summary. So I thought, if anybody has any questions on those two things, we can ask those as well right now.
Great, Mark. Two points. One is for folks who want to get to an even more in-depth dive. Our prior webinar, if you go to nsma.org, that was our professor that day was George Kaiser, and we had an in-depth 6 gigahertz webinar if people want to get even more in-depth. And of course, as is implicit in Mark's statement today about a relocation band for incumbents at 6 gigahertz, maybe going to 7 and 8. There are quite a few interference concerns, and they are elaborated on at length there. There is a statement from Joseph Crossan. He says that with the estimation of the number of unlicensed devices, numbering in the billions, by 2025, how concerned should critical infrastructure operators, we're talking railroads, electrical grid, waterway sensors, et cetera, running major dams, things like that, be in regards to interference into 6 gigahertz?
That is a great question. I can take it down a level. So, and I think Joe probably knows that, or a lot of people probably know what's going on, is that the commission for the band punted a lot of the technical work on how to do sharing to a multi-stakeholder group. And so the multi-stakeholder group is in the formation stages, and a lot of the critical infrastructure folks are participating. So UTC, EPRI, Nuclear Energy Institute, a lot of those guys are participating in the discussions, and we have to figure out how to make it work. The commission has spoken on the whether or not low power indoor will interfere. They said it won't. And so that means that the major focus of this effort has to be on one aspect of this multi-stakeholder group, which is addressing interference detection and remediation. And so within the context of this multi-stakeholder group, that's the one area of which there is a lot of interest. If anybody is interested in participating that is not aware of that, but that has interest, let me know. My contact information is in the deck, or you can contact me at mgibson@commsearch.com, and we can get you involved with that. I am the chair of the WIN Forum. The Wireless Innovation Forum is studying this band. along on the you know, along with the Wi-Fi Alliance. But the WinForm is studying this, and I chair that effort, and have been very active in getting this multi-stakeholder group going. So if anybody is not aware or is aware and wants to participate, please let me know. And we have a lot of work cut out for us, but I am pretty sure that under the spirit of cooperation, collaboration, we'll get it done.
Yeah. One, while we're still on that, and then there's an opportunity for Mark Rasick to comment. But prior to while we're still on 6 gigahertz, there are. I'd be curious how this lands with you, Mark. You know, there are clearly still a large group of incumbents who are, as intimated by Joe Croson's comments, and also by the presentation made at NSMA's last webinar by George Kaiser. There is a long inventory of concerns about the low power deployments, and there is some live testing that has been. There's an opportunity for live testing prior to the billions going into the market, billions of devices, and there's a growing collaboration with a subset of the multi-stakeholder group on working on gaming out replicable interference, you know, worst case, best case interference scenarios. And if data appears that there's something that really needs working out prior to the launch of the billions of devices, you know, that's sort of the golden opportunity where the window's open. So I'm saying all that by way of trying to bring some voice to that concern by mission critical incumbents. Yeah. And in some cases, the multi-stakeholder group might need a smaller group. This is one thing for folks to think about. I need a smaller group to go and do their homework and bring it to the multi-stakeholder group. Yeah. And I think you mentioned this, Mark, but just to underline it, the multi-stakeholder group, you know, was encouraged by the FCC's 6 gigahertz order, including participation by government officials, including the FCC. So, you know, the idea is to be constructive here for everyone to share data that's replicable. And so everyone concerned is, you know, we want to be standing on the hill and making sure the trains running from one side of the hill to the other side of the hill full blast at each other.
I couldn't agree more. But I would suggest that anybody that wants to further study the band, you know, paper studies, I won't comment one way or the other, but you can tell from the Commission's lengthy response to those, especially AT&T study, that they're not interested in paper studies anymore. So, and I know this is implicit in a lot of what, in fact, explicit in a lot of what the critical infrastructure folks are asking is some facility to conduct measurements. So that is where this is going to be dealt with, is actual measurements with good metrology. So whether or not the multi-stakeholder group is the place to do that, we have to talk about. I don't think the Commission was interested in dealing with that to drive the discussion of whether interference is going to happen, but more how we deal with it. And that's a valid concern. And I think the Commission punted that, you know, punted it and threw it, and I don't know how we gave it to the multi-stakeholder group and said, you guys do it. And I think that the reason for that was that, from the most part, the Commission's, you know, as you all know, and I think George probably talked about this in his session, the Enforcement Bureau has kind of been decimated, and all they're dealing with right now is really major issues. And I won't argue that critical infrastructure interference is not major, but they also don't have a lot of manpower or person power to handle a lot of incoming complaints. So what has to happen within the multi-stakeholder group is a framework that industry can manage this. And it's similar to what we're doing in CBRS. In CBRS, the FCC has asked the SASs to handle a lot of the enforcement, incoming at least. And so I think if people are interested in this, this is a work stream that's been established in the multi-stakeholder group to deal with just this. And as the chairs of this multi-stakeholder group, or of this work stream, represent some of the major incumbent microwave operators. So again, I would say that if anybody has concerns that are not aware of this effort, you know, let me know and I'll make sure you get involved with it. But you know, there's a lot of work to be done, and we need to hear from all sides. And so we've heard a lot from the critical infrastructure folks, but you know, if you are out there and your critical infrastructure don't know about this, you know, let me know.
Yeah, great. That's very helpful, Mark. One thing before we turn to Mark Rasick and for 7 and 8 gig band, one other element in the 6 gigahertz band, Andrew Lyman asked the question, you know, what, if anything, do we know about the Google experiment in the 6 gigahertz band in about 17 states?
That's only propagation measurements, really. A lot of people look at Google, and when Google does something, it's kind of like, whoa, Google's doing something. But and I can know the Google probably was a little bit naive in their thinking that they could do an experimental in this band and no one would notice. But I talked to the guy that's doing that, and he said, look, all they want to do is collect their own data for propagation measurements, and that's it. And I trust the person. I know the guy pretty well. So I would say this is really nothing more than what they said in the rule or in the STA or experimental, which is they're just collecting data for propagation. It's not that Google's rolling out sort of a secret, 6 gigahertz system. They're just trying to collect data on propagation in the band, because most of the propagation measurements that have been made in this band are for microwave, not a lot of measurements in clutter. Certainly not a lot of measurements for low power operations. And so this is mostly what these are about.
Great. And this, thank you for that. And then if Mark, if you're on for a little comment on 7 and 8 gigahertz, this is an opportunity. Mark Rasick, if you're unmuted and still
okay. So thanks NSMA for hosting this, and Mark Gibson. It's been a very interesting presentation. Just a comment about 6, 7, and 8 gigahertz. Fully support the what CommScope has said. There is substantial opportunity, I believe, here. As you probably are aware, is that in the 6 gigahertz, you have the lower and the upper 6 gigahertz. They actually have different channel bandwidths that are allocated. The lower 6 gigahertz is 60 megahertz and the upper is 30 megahertz. And so we have very limited sort of spectrum that can be used for long distance backhaul. And to be able to support sort of the 5G gigabit type of speeds that we're envisioning, you need to have at least 60 megahertz. And so I think that with sort of this, the plan that would allow support of commercial fixed service in the 7, 8 gigahertz allows that opportunity. It very much, according to the NTIA band plan, you can be able to aggregate 230 megahertz channels for 60 megahertz channels and be able to support the type of 5G services that we're envisioning. So I just wanted to go ahead and say I think it's sort of a great idea.
Thanks, Mark.
Thank you, Mark Rasick. Joseph Husney, if I apologize if I'm not pronouncing names correctly, was also asking how might we get a copy of the slide deck. We'll be posting them on nsma.org. I think Mark Gibson was going to update the December 20 comment date on, but beyond that, 2021. Beyond that, if there's any other questions, this is a good opportunity to weigh in. And I don't think I see any more, but let me double check one other bar. I think that covered it from any written questions, and I don't see anyone else has raised their hand. So I'd love to take the opportunity for Mark for you to run through your summary slide.
Okay.
Then,
So in summary, 3100 to 3550, lot of work still to be done in the band. Whether we need to study whether there's sharing, got to go down and meet with NTIA. And like I said, the commission has a rulemaking coming out, and there may be a request for some more information from that. The C-band, lot of activity going on right now. What I didn't mention is there's 4 technical working groups working just on how to share in that band. And there's a lot of work being done on setting up the transitions of the earth stations. Wait a minute, what was that? Yeah, I'm sorry, it was CBRS. Got out of it. CBRS, we just finished the auction. SASs are working. We should be, CBRS is full speed ahead as soon as the public notice comes out. C-band is what I was talking about a minute ago. Now the 5150 to 5925, it's the hotbed for wireless internet. I get my internet from a WISP in that band. I'm a consumer of that product right now. And moving on up, the 5925, the 6 gig band, you know, all of those that are on this call that have interest in that band, especially in the multi-stakeholder group, please let me know, and we'll get you in on that. And finally, the 7125 to 8500 is the 6 gig band, the 7 to 8 gig band. Lots of stuff going on there. We think that there are plenty of ways that that band can be open for sharing that may or may not effectuate some need for frequency coordination. So that's pretty much it. Thanks everybody for all your questions. And with that, I'll turn it back to Joe.
Thank you, Mark. Your 36 years of experience in the industry is paying off, and for us, we're very happy to have had you today. And you know, this is very, very useful. As a reminder to everyone, the presentation will be posted. It's also been recorded, so we have both the PDF available soon, and a note will go out to every participant about the PDF being available, as well as the recording itself. We also have an archive of our prior webinar, and we have a series of webinars upcoming. And also encourage you to look at the NSMA website, which has a very deep archive of presentations for many, many years in a row from worldwide experts in almost any band you can think of, and almost any category of spectrum management you can think of. So stay tuned for more. Again, thank you for your participation. We appreciate your interest. And I do note that another thing, I'm exceedingly proud of just the participants. You see quite a few incredibly accomplished people in all walks of life participating here. So it's a real blue chip group, and good to see everyone out today. So thank you all, and take care.
Thanks, everybody.